Hi guys. Okay, we're out in the shop today and we got a little project going on here. I have an old engine that's been laying around for about the last 25 years, so cleaned the dirt off of it and got that set up on a test stand. And so we're going to fire that thing up so you can see what's going on there. Found a cheap deal on a centrifugal clutch for it. Okay, so this is the beginnings of my band sawmill. So I made a backbone out of 6-inch wide channel and cut an inch off and then put them together, so this ends up being a 2-inch wide tube. I V'd out the surfaces of it pretty good here and then laid a weld down into it, so it's a good solid tube now. And these pieces here are 8-inch channel. And I've got some mounts welded in here that are just sections of some tube that I had laying around. Okay, so the idea is to weld this piece onto this piece. I have this plate here that's going to be my bearing carrier. It's 1/2-inch steel plate and it's bolted onto the back side of the plate. There's a 1/2-inch spacer in here so I can get these bearings 1 inch apart. So I've got a face bearing here and a face bearing on the underside. And these things here are going to be the adjusters. What I did is cut off some cap screws and center drilled them. And I threaded my bearing plate so that that screws into it. After this channel is welded onto the backbone here, this plate will get mounted on here. There's 3 bolts that secure it to the mount. So basically what happens is these adjusters here, since they pass all the way through the plate, they form a tripod with the 3 of them. And by turning this in, you can see that it's raising the plate up down here. So that will give me the ability to adjust the axles true on this for the band wheels. Obviously the shaft for the band wheels will be going through the bearings. This is laying on its side. But you'll have a 3-way adjustment here to angle the shaft as needed. There's a pretty good amount of force on the band wheels when you tension them, so having the ability to adjust them and square them all up and even compensate for alignment errors of the parts themselves is going to be important. And once those adjustments are made, then these screws here will just be screwed down into the mounts of the channel, and that'll hold everything in place. Well, this end here got a little more complicated. This has got a bearing carrier here, which is a 1-inch plate that's separating these two bearings, and there's a notch cut into the bearing so that it's sliding on these two pieces of bar on each side, and it's able to go back and forth in here. So that'll be what's used to tension the blade. I've got the same arrangement with the 3 adjusting screws on 3 spots to make that tripod effect. And okay, so again, used 8-inch channel for this. Used some sections of tube for mounts, welded some nuts underneath of them. This will be welded onto the backbone. And the adjuster assembly goes onto that. Okay, there's the bearing carrier. It's got a screw that's threaded on the end of it that goes into the bearing carrier, and then this nut here tightens it on so it can't back out. And these are the grooves that the slide goes into. Okay, and then this one works the same way as the other side. When you tighten up these adjusting screws here, it lifts the plate up off of the framework of the bandsaw backbone. It allows you to shift the axis of that band wheel axle in all directions necessary to get your alignment. And I've got this assembly just put onto a bolt so I can keep track of it, but you'll see it's a stack of Bellevue washers. And Bellevue washers are just spring steel that have a cup to them. And they're stacked together in an alternating fashion to give them clearance between each other so they can be compressed. And then down here I have a thrust bearing, and to load it in here, Now this tube is bored out larger on this outside than it is on the inside, so there's a step back here on this side for the washers to set on. I could have just welded a piece of plate onto the back of it like a washer, but I just went ahead and bored a solid piece of tube out so that it worked that way. And eventually there'll be a handle welded onto this for making adjustments, but right now you can see that as the screws tightened up, it pulls this bearing assembly along the slide, and this is in the direction that would tighten the band up and put tension on it, and then the springs in here would compress in order to maintain that tension setting. So I'm going to go ahead and break this down again and get those mounts welded onto the backbone, and then we'll come back and see how the shafts and band wheels install. At this point, put the bearing carriers back in place, put the shafts in and mounted the wheels on them, and put a blade around it, and the adjuster seems to work okay. So I believe right now the plan is I'm going to take a belt, probably not this belt, but one similar to it, and mount a idler pulley of some sort right in here. We'll use this belt right here as a band wheel for the blade to ride on. It provides just a little bit of crown, kind of a tire for that belt. So we'll get this all welded together. Okay, figured we better start doing an update on where things are going here. Took a little time off and collected some salvage material from pallet racking. I was originally going to use pallet rack sections for this, and they're just made out of sheet metal. So it was originally a piece looked like this. It was a lot nicer material that I had, and they were complete racks, but they are kind of flimsy, and so I decided to go a different route. So now we're going to use C-channel, but I have all these different pieces of pallet racking materials that I'll use for bunks. Got some angle iron over here that we will use for the rails that this all ride on. Got some 3-inch channel using for crossbars in the frame, and then this is going to be the frame here. I have 4-inch channel here that I'm going to make into 3 8-foot sections, and then there's the rest of them there, and that'll all bolt together into a 24-foot long bed. These will be what holds the saw to the masts that it rides up and down on, and there'll be a pair of those that surrounds the vertical tubes. And then I've got some of this UHMW, and it's wear resistant plastic. It's supposed to be slippery, and it doesn't wear. It's supposed to have a better wear rating than steel does. So with the lubrication quality and the simplicity of it, I decided that was the better way to go. Next step is going to be to tack weld these sections together.
Alright, we got the rails welded together. This will be the subframe for the rails to sit on. Got 3 sections here that are 8 foot long, so we got a 24-foot bed. Never cut anything that big, but it's always good to have the option. Have 2 of the 4 12-foot rails prepped here so that those can get put onto the bed. This will be what the saw head rolls on. And these were the brackets that were welded onto the ends of the pallet racking originally, so ground the welds off the back of it, put some holes in it. These plates here will get bolted inside of the rail sections on the back side. That'll be what holds each section together. Okay, we need to put some levelers on the bottom of the frame here, so I got these bolts and I stuck them in the lathe and put a little shoulder on it, and then this washer will get welded onto it here, so that'll end up being the leveling feet. And then I took one of the nuts and put a little shoulder on it also. So drilled this out with a hole saw, that registers in there, and we'll put a weld around it in a couple of spots to hold that on there. And then the feet will screw into the bottom of it. Gives us a little bit of a range of adjustment. And so get those welded together. Only 17 more to go. So here are the nuts welded to the rails, and the leveling feet are put together, faced off the weld so they're flat in the bottom. And that'll give us some adjustment across the bottom of the frame. Alright, this is yesterday's progress. Got 12 feet of the rail on top of the frame. Here are the wheels that the saw will ride on down the rails. There were some pieces of bar cut off that I had, so I just went ahead and machined them to work for wheels, put the grooves in them to set on the tracks, and got the pockets cut in the middle of them, and got some cheap bearings here. Got a whole pack of them there. So we'll put a bearing in each side of it. There'll be one here, and one will press in on from the other side, and that'll be what it rolls on. Well, this is where we're at today. Just doing a mock-up of things at the moment to make sure that everything's coming out as was expected. A lot of this was just built with things that were laying around, so some of the dimensions and things were depending upon what kind of materials I had on hand, but so far everything looks pretty good. From the bunk down at the rails to where the blade's at right now is just slightly over 24 inches, so that should be a pretty good height. I'd planned for this to be able to run a 26-inch log, so that'll fit in there, and the first cut's going to obviously be 2 inches down into the log, so that's pretty much normal for the way sawmills are designed, so this one should work okay. So I got about 3 inches to take off the top of this and finish building the frame for it, and then we can better see how things are going to work out. I have this piece of tube that got at an auction many years ago. I found a motor mount in there, which will be attached to the backbone of the saw, and that's what the engine will sit on. And got the sides of the rolling frame done here. it rolls along pretty easily. Doesn't take any effort at all to push it, so that's working well.
Couldn't find an idle pulley system to use on the mill like I intended, so I got a couple of pieces of 3/4 inch thick cold rolled bar already boarded out inside for these Harley 1-inch wheel bearings that I had laying around. So that's going to end up being the idle. We'll just bolt these two halves together. We'll put V-grooves in it for the belts, and I'll have one that drives off the engine, the other one that drives the band wheel for the saw blade.
I guess before I race along too much further, this is the pulleys after they were finished. There's one pulley here and there's one here, and it's spaced by a 1/4 inch spacer. I needed that because we're going to have the belt passing down between the saw blade and the head of the saw, and I need this extra space here for the overhang from the blade that'll be off the band wheel. This will drive the band wheel. I've got some 1-inch Harley Davidson bearings, roller bearings in it, one on each side, and the 3 pieces are bolted together with the bearings pushed in there. And then this is a pin from a tractor 3-point hitch, and I machined the end of it down to fit the bearings. At any rate, this assemble on that. Got a screw here to retain everything, and then this whole thing will be bolted into the face of the saw head backbone, and this will provide a point where the motor can turn this pulley, and then this pulley will be turning the band wheel. So it's just basically a jack shaft for that operation. And as you can see in the background here, we've got the screw assembly started for the jack system that will be lifting the head of the saw. I'm adding on the rest of the track for the sawmill, and this started out as some salvage 3x3 1/4 inch angle, and it had brackets welded on it. I cut the brackets off, gave me some 12-foot 6-inch pieces. I cut down to 12 foot, so I got 2 of those to make a 24-foot bed. Cut this down so it's only 1.25 inches tall now, and of course if you cut it off it's going to be pretty rough. Trick was to get it all smoothed down so it was all equal height, and you can see on this side here that I've been doing some grinding on it. I've got a pretty flat surface on there, and originally wasn't going to show this, but what the heck, we're building sawmills, so what's dangerous? What I did is I made a trolley for a bench grinder, and you can see it runs on ball bearings down here, so it sets on the surface of the angle, and then the wheel contacts the top of the track. And then over here I've just welded in a little piece of metal there with a hole in it so that this all thread had a place to register, and can turn that with a wrench, and that raises and lowers the bench grinder. So
By rolling it along the length of the bed, I can get the heights between here and here pretty accurate.